Hello, I'm Edward Tarte, math teacher. I have a math lesson for you followed by a challenge based on the lesson with prizes available if you want a prize. At the high school where I taught for many years, there were two math lessons taught at different times in the school year, sometimes taught in different courses. The two lessons are actually closely related, but as far as I know, that relationship was never mentioned at the high school where I taught. I want to present those two lessons for you briefly in this video, side by side, so that you can see them together and, I hope, discover the relationship between them. The first of these lessons is about Pascal's triangle. I made an earlier video about Pascal's triangle. If you haven't already, you may choose to watch that video. But I'm going to go over Pascal's triangle rather briefly now. It is an array of numbers in the form of a triangle that goes on indefinitely. I put a 1 at the top, and below it, in every location that you see here, I'm going to put the number of ways of getting to that location working from the top down. For example, in this location, there's only one way to get to it from the top down, and that's to go to the left continuously along the left edge. To get to this location, there's only one way, and that's to go to the right continuously from the top along the right edge. Indeed, we see that we need to put ones all along the left edge and all along the right edge. As for the interior numbers, this location, there are two ways to get to it from the top: left then right, right then left. Very simply, 1 plus 1 is 2. Concerning this location, how many ways are there to get to it? Well, there are two gateways to it, the two locations above it, above to the left and above to the right. And since there's one way to get here and two ways to get here, there are three ways to get there. 1 plus 2 is 3. And that's the key to filling in the interior numbers. You add the two numbers that are above it, above to the left and above to the right. 1 plus 2 is 3, 2 plus 1 is 3, and so we have on this row 1, 3, 3, 1. On the next row, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so the next row reads 1, 4, 6, 4, 1. The row below that, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. And so we have 1, 5, 10, 10, 5, 1. And below that, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. And so we have 1, 6, 15, 20, 15, 6, 1. That's Pascal's triangle. Now the other lesson is about flipping a coin. If I flip a coin repeatedly, how many possible outcomes are there? Well, if I flip it only once, it might come up heads or it might come up tails. I'll put H, T. H for heads, T for tails. That's two possible outcomes when I flip the coin once. If after that I flip it again, if it comes up heads first, it might come up either heads or tails after that. So I will branch out accordingly, like that. If it comes up tails the first time, it might come up the second time either heads or tails, which gives me these outcomes. Heads, 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 tails, tails, heads, tails, tails. That's 4 possible outcomes, 4 possible sequences. If I flip it a third time, I can show the results by branching out from each of these outcomes. From this H, I'll put an H and a T. From this T, I'll put an H and a T. From this H, I'll put an H and a T. And from this T, I'll put an H and a T. And so with 3 consecutive flips, I can have these outcomes. Heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. That's 8 possible outcomes. And I don't have room, but you can imagine the branches continuing to show the results of flipping the coin 4 times, 5 times, 6 times, and so on. The number of possible outcomes, do you see the pattern? I'm sure you do. 2, 4, 8. What do you do to one of these to get the one below it? You double it. You multiply it by 2. And so that pattern, we understand that that pattern continues. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So if I flip a coin 4 consecutive times, there are 16 possible outcomes. If I flip it 5 consecutive times, there are 16 times 2, 32 possible outcomes. If I flip it 6 times in a row, there are 32 times 2, 64 possible outcomes, and so on indefinitely. So that's a lesson on flipping a coin. Now, here are the 2 lessons side by side. Can you see a relationship between the 2 lessons? Can you see how to get from Pascal's triangle these numbers of possible outcomes of the coin flips? 2, 4, 8, 16, 32, 64, and so on. What can you do to numbers in Pascal's triangle to get that list? If you can see that and also describe in your own words what relationship or relationships you see between Pascal's triangle and flipping a coin, I'd like to know about it. But don't tell me at the comments section of this video. Instead, go to my profile page, click on Send Message, and message me your answer. If I like your answer, and I probably will, especially if you can tell me how to get these numbers from here, then you can have a prize if you want it. The prize that I offer is an audio file of me playing my piano, a selection that I recorded several years ago during the years that I was teaching at the high school. If you need help deciding whether you want the prize, you can access my piano videos playlist at my profile page and watch one or more of those. If you want the prize, be sure to include your email address. I hope that you have enjoyed this video and that if you work on the challenge, it will give you mental stimulation and pleasure. Thank you for watching this video.